everyone, welcome back to the workbench. We've got here again the Lenco A50, and after my mishaps and my stupidity in the last video, I had to let this rest for a couple of days before continuing to work on it. But now I'm back and I have the courage again to continue the work, and the goal is to get this one fully working now, finally. If you missed the last video, right at the end when I was adjusting the bias, I made a short with my multimeter and I blew this output transistor. I disconnected here just to 100% surely check that it's shorted, and indeed, yeah, it is shorted. So I've had it with cutting corners. I'm just gonna replace all of the output transistors. So only this one is blown, the other three, they will go in my parts bin. You never know, for a future repair. I've got 4 new output transistors, 2 times 2N3055 and 2 times an MJ2955, the complementary transistor for the 2N3055. So I'm going to take out the original ones, clean up the heatsink, apply some new grease, silicone grease, mount the new ones and hook everything up again. And in the process, I'm also going to check if I didn't create any other issues, because I've also blown this driver. That one was already replaced. I'm just going to check if I didn't create any other problems. And I'm also going to recap everything, which I haven't recapped yet. So on the M board, there are only a couple of caps left. But here on the other boards, like the power supply and the phono stage, I'm also going to recap everything, because as I said, I've had it with just cutting corners and measuring capacitors and these kind of things. I'm just going to bring out the big guns here now to get this working. So that's what's coming up now. First thing to do is get this board here loose, because I need to access that side of the heatsink and start replacing the output transistors. Okay, these two have already been removed and cleaned up. That actually went quite well. Also, getting this board up was not that difficult. You just have to remove these 4 screws and then you can lift the entire PCB up, or you can tilt it upwards. So I put a box here in between to keep it in place a bit. And now these two here, I'm also gonna change those, even though I think that they have been replaced because the original ones were blown. I still have no clue how old they are or how their life has been. And I'm gonna replace them to have matching transistors on both channels. So these are also coming out. And oh, these are very well in the socket. Oh, come on. And this is always a messy thing to do, because my fingers get grease all over them. Is there no mica insulator here in between? Ha! Okay. The mica insulator was missing, so that means that here on these ones, here we do have a mica insulator, but on this one, no, it's completely stuck against the, yeah, it's there, but it's stuck against the heatsink. So yeah, let me also clean this up here, because it's a mess. Okay, so the new transistors are in. I also used new pieces of mica, because the old ones, yeah, I didn't feel like cleaning them up. One of them was damaged anyway, so I just used new pieces. I'm gonna put the PCB and heatsink with the transistors back into the chassis, and then let's see if I did everything correctly. Okay, we are back in business. Look at this. Ta-da! Both channels, I guess. Yeah, both channels indeed. At first sight, they are tracking quite well. See, we are here again at this dead spot on the volume control, and I also have quite a bit of restrictions still. Well, not quite a bit. I do have the dim bulb limiter in there still. So, but at least we have an output. Let me turn down the volume and let me see what do we have in terms of DC offset. 44 millivolt and dropping, so around 40 millivolts on the right channel, and on the left channel we got still our 78 millivolt on the left channel. But yeah, and this one is dropping, it's already dropped to 35. This one is also still dropping. Okay, that seems okay, I think. I'm just gonna let this warm up a bit just to have a better idea of how many DC offset we actually have. And then I'm gonna recap the remaining stuff that is still needed here on the on the amp. Okay, the recapping has been done. The power supply board, the phono board and the amplifier board were fully recapped. And I have a tone connected now, and I have the speakers connected. And it sounds like it's working fine. Wait, let me give some extra light bulbs on the dim bulb limiter. Yeah, that's maybe a bit of an irritating tone. Let me go a bit lower in frequency, maybe 400 Hertz. And the switches here are not noisy anymore. The balance control is working. Left channel, right channel, both channels. So everything seems to be working okay. I'm thinking about hooking up some music maybe through now the speakers are connected. Okay, so we are back at the same spot where I blew the output transistor in the last video, so hopefully no firework this time. I have had the amp running here for now for 10 to 15 minutes, letting it settle. I'm measuring the voltage drop across one of the emitter resistors on the left channel. And it's reading around 15 millivolt, and it's a .33 ohms resistor, so that means you have to multiply this by 3 to get the idle current, and then we get around 45 milliamps of idle current. Now, I don't, as I already explained in the last video, I have no instructions on what the idle current should be on this amp, but 45 milliamps seems to be in the correct ballpark. It could definitely be lower, but I'm gonna leave it at the moment like it is. I'm giving the amp 240 volts now, so in real life it will come down even a bit more because voltage here in Europe at the moment is 230 to 235. So I am quite happy with this 15 millivolt here on this channel. Now let's also measure the other channel, and let's try to do that without touching anything and blowing up any of the transistors. So I am using different leads compared to last time. So and I'm gonna be very careful. Okay, let's connect these leads one by one and make sure that I don't touch anything. Here on this side we have 15.7, so maybe we can take that one down a bit. Let me get my screwdriver in there. Oh, no, that one is too big. Oh, wow, that shot down quite significantly. Well, I'm thinking maybe this 15 millivolts is also a bit high. Let's say we put it to 12.5. Wow, it's very twitchy, very difficult to adjust. That's 13. That's 12.3 and climbing slightly. Yeah, that's more or less 12.5. Let's check the other channel again. Here we still have our 15.5. Let's put this one also on 12.5. Wow, that's really twitchy. Okay, I don't know if that pod is still good, but that one is really, really difficult to adjust. I'm not touching it and it's moving all over the place. I think I need to clean this pot because I really can't adjust this. Yeah, let me clean this pot and then we'll check again. Or oh, that's close enough. Yeah, that's close enough. I'm gonna leave it at this. Okay, so I've got some music playing. Now, I don't know how well you're gonna hear this because of the microphone, and also because I'm using these small monitor speakers here in on my workbench, which don't have any bass at all. So, but hey, it's working. See? Treble. Bass. Whoa! Whoa! Wow, what was that? Jesus. Wow, that smells good. We have a fried resistor, and I hope it's only that. Man, boah, that smells bad. Interesting. Lucky I don't have a smoke detector here. Man, that smelled bad. Oh, we have a blown transistor as well. See, this transistor just blew his top off. And that resistor blew open. That was still one of the originals, I think. Yeah, that's I haven't replaced that one. That's Q507. Q507, where is it? Which one is it? That's this guy. Let me just see, that's this one in the current limiting circuit that I showed you explained you in the last video. So these transistors, they basically yeah, they turn on when the current goes too high between the outputs, and then they, if the current goes too high, they shunt the inputs out so that the outputs cannot go over current. So yeah, I guess that one wasn't good. That's spectacular. I have to say I'm a bit yeah, how do you say it, shocked a bit. My heart rate is going a bit higher as usual, I think. So let me see here. Do we have a short on the outputs? Not on... Oh no, do we have a short? Ah, did I blow the outputs again? Don't tell me that I blew the outputs again. I've really had it with this amp. I've really had it with this amp. Okay, let me calm down here a bit and let me investigate again, because I think again one of the outputs shorted, and I don't know why. I really don't know why. Okay, so I pulled the potentiometer. By the way, the other transistor in the current limiting circuit is also bad. Yeah, it was also blown. I think both outputs on the left channel are both blown. This is the potentiometer that I pulled. According to me, this is supposed to be a 500 ohm pot, but if I twist and turn it, then see, now it's going down. Okay. But here in this direction, see here I'm not touching it at the moment. It's all over the place here. See, now it's again 500, 700, 800. I think this pot is bad, and I'm not sure if that is the reason for this big failure. It could be that the bias just went through the roof suddenly. I don't know. No, it's, what is this, 90k? I am measuring correctly here. Yeah, this is 34k now. Wait, that's not, almost not possible. 200k? I think this might be the problem. I'm not sure. I don't know. I mean, the explosion happened when I turned up the volume. So when there was a lot of power going through the amp. I also still had the amp on my dim bulb limiter. That shouldn't be the reason why it would explode, right? But definitely these pots are definitely bad. I need to find a new 500 ohm pot, and preferably a 10-turn one, not something like this. But yeah, back to the drawing board, I'd say. So here we have the casualty list of our cataclysmic event. Both output transistors, both drivers, both transistors in the current protection circuit, of which one of the two completely blew his top off. The other one simply shorted. Then this was this resistor that heated. It completely opened up due to overheating, and that was the resistor. Let me show you. This one over here on the emitter of one of the drivers. That reminds me, I have to check that one as well. And then this guy also failed, and that was Q504. So that's this one over here. Yeah, so quite a bit of casualties here. I think I need a break again before continuing on this because, oh yeah, and then obviously the potentiometer as well. Now I don't know if it is linked to this event or not. I think it is. I think it might even be the cause of all of this. But it's definitely bad and needs to be replaced. So, yeah. Now I have to replace all these things again. But I think I need a break and a beer first before I start on this. Okay, so we are the next day here, and in the meantime, well, I've had my beer and I've slept about it. Well, actually, I've been lying awake a bit about it, and I didn't feel really good, actually, because I was thinking, am I this stupid? I just blew up the same channel twice? Okay, maybe in a different way. The first time I really make the short myself, but this, I don't know what I did wrong. So, yeah, I was really starting to doubt my own skills and my technical skills here. And I was really thinking, am I just too stupid to do this? Or what is going on here? Because I couldn't understand really what happened. And so I watched the footage again. And in the footage, it's quite interesting because you can see three things happening. Right in the beginning, you notice that when the music starts playing bass, so you see there is first a piece of music which doesn't have any bass, but as soon as the bass starts, you see that things go wrong. And there is this one transistor which explodes, well, in a magnificent way, which completely blows its top off, and that is one in the current limiting circuit. Then the next thing that happens is one of the emitter resistors of the driver stage burns up completely. And then the third thing, if you notice closely, is that the potentiometer to set the bias also burns up. So I'm not sure if this is now, because I mentioned earlier that I thought this might be the cause. It could be just also a victim of what happened. If you see it in the video, there is clearly a spark coming out of this potentiometer here, which really, yeah, made me even more confused, and I had no idea anymore what was going on. So I said to myself, well, let's just try again. So I wanted to go to the local electronics store again to buy some new transistors, to buy also a new potentiometer here. But because I don't have this 500 ohm pot meter. But just before I wanted to leave, I thought, what if there is something wrong with the transistors that they sold me? So I googled fake 2N3055, and I found quite a bit of interesting videos and articles about these transistors being often faked. And I found a website where they open up a transistor and claim that it's fake. And then I did the same to mine, and look at this. Wait, let me pull you in a bit closer here. So this is the 2N3055 that blew up yesterday. It didn't blow up dramatically like this, huh? I cut it open. But if you look on the inside, yeah, that looks suspiciously like the images shown on that website. See, the die in there is extremely small. It's just glued directly to the metal plate, and the wires for the base and the emitter, they are really thin. And just out of curiosity, I also opened up the MG2955, which also blew up yesterday. And if you look how that one is made on the inside, it's a big difference. See, it's not directly onto the base, but you have these ripped plate in between. The die is quite a bit bigger. The wires are also thicker. If you compare that to this one, it's quite a difference. So I think I got hosed. I think they sold me counterfeit or fake, or in any case, very cheaply made 2N 3055s. So if I would go back to that shop, I'm now talking about a local electronics shop here close to where I live. It's not a big international electronics supplier, but it's here in Belgium, quite a well-known shop. And yeah, it's not that I bought these from an shady seller on eBay or anything. So I'm definitely gonna send them a mail and complain about this, because I think this might be the problem. Maybe this guy blew, and that caused a chain reaction in the entire amp, taking out 7 transistors in total. So yeah. The problem is that I thought, yeah, now I'm stuck because I need to order then new transistors online on another source, like from DigiKey or something. I also need to order these, a replacement potentiometer. But I mentioned also in the previous video that I have quite a bit of a stock of old scrap PCBs. So I went through them and to see if I couldn't find anything useful. So I found these PCBs here. Just give me a second. See, and they have a 2N 3055 on them. I found 2, exactly 2. Now, I don't know what they were originally used for, probably some kind of power supply. I don't know their age either, but the capacitors on there are still marked with West Germany. So this must have been from the 80s. So these are definitely not fake. No, I don't know if they are still good. I can pull them and test them and see if they are still okay. Yeah, so that is good, because now I have 2 not fake 2N 3055s, and I also still have from which were originally in the amp, I still have these 2, which are also a 2N 3055 and an MJ2955. So maybe they are not all perfectly matched, but I think I have components enough to continue. And then for this potentiometer, same thing. I found this PCB. Also, I don't have any clue what it was used for, but there were some 10 turns, or maybe even more than 10, maybe 25 turn pots on there. And I salvaged these 2, and these are 500 ohm pots. And they are really good quality. They are Born pots, and they are still available today on DigiKey. And they are quite expensive. I think they are like €2 each. If you would need to order them today from DigiKey, they are, I looked up the code, and it's half a watt, 500 ohms. So these should do fine in there. So yeah, I think I have all the components I need to continue with this at the moment. Well, first thing I need to do is get those 3055s off here and see if they are still okay, because if they aren't, then it's already game over. This might take me a bit of time to get everything rebuilt here, putting new transistors in, getting everything working. So I think I'm going to leave it for that in this video. I'm going to rebuild the left channel completely again, and then you will see the result in the next video. So again, I am not giving up, and if you have an idea what went wrong here, other than this potentially bad 2N 3055, let me know. Maybe I did something wrong and I didn't notice, or maybe I made an oversight. Do you think it is because this transistor is blown? Do you think maybe an oscillation caused this? Do you think maybe it's the potentiometer? I don't have a clue. So any suggestions are welcome. So anyway, enough waffling. I'm gonna get to work here, and I will see you in the next video. Take care. Bye-bye.